tolakkan dengan 1/5 X. Betul? So the model becomes what? Dx dt plus 1/5x equals to 6. Okay, are you all with me?
Yes,
Yes.
Doctor.
Okay, so this is a first order. This is the model, right? This is the model presenting the problem. Okay, right. So once we have the model, we want to solve the equation lah, the differential equation. So the model is dx dt plus 1/5x equals to 6, right? And this is a what? Betul? Okay. Okay. Actually ada cara lain nak selesaikan benda ni, tapi katalah kita anggap dia sebagai linear. Okay. You boleh anggap dia sebagai another type of differential equation. Okay. Katalah kita anggap sebagai linear. So what do we do? First, in order to solve the problem, you want to find the integrating factor, isn't it?
Yes.
Betul. Okay. So, sorry. P of t. Tengok tak sabar ni. The P of t, remember it's a first order linear, so P of t is simply 1/5. Okay, recall apa kita buat untuk selesaikan the first order linear differential equation. So from that you come up with the integrating factor, which is e to the power of integration of P of t, kan? Betul tak? Are you all with me?
Yes.
Habis
Yes,
orang dia
Doctor.
kata yang lain tak ada suara, macam mana ni? Penat Nabil Okay, so dapat bentuk ni kan? Alright, so what do we do next? Multiply
Both sides.
both side. Macam biasalah ni kan, both sides of katalah kita panggil dia star lah star ni dengan the integrating factor, which is e to the power of 1/5t. So you have e to the power 1/5t multiplied by dx dt plus 1/5x, right, equals to 6e to the power of 1/5t. Okay, remember, I don't have to re-explain to you. So this, by multiplying the expression on the left-hand side of the standard first order linear differential equation with the integrating factor, you can actually simplify it into d dt, the integrating factor, which happens to be e to the power of 1/5t. Okay, and then dia punya 2x lah kan, betul tak? Betul tak? We don't do anything to the expression on the right hand side. Okay, alright, kalau you percaya tak saya cakap ni, you differentiate balik benda ni, you should be getting benda ni. Okay, alright. So we would like to solve the equation, right, accordingly for x, right, x with respect to t tu. So you integrate both sides, right, because integrating will eliminate the derivative. So you integrate both sides and 1e to the power of 1/5t. Okay, the derivative disappear, but the expression on the right hand side is being integrated with respect to t. Am I going too fast? Okay ke?
Okay je.
Je. Ada titik betul ke saya tulis ni? Awak rasa betul ke? Tak betul. Nanti kan tulis pula. Make sure you salin yang betul lah. Kan? Betul tak? Ni sama dengan apa ni? 30
Betul.
Okay, plus C lah. Sebenarnya you can cut the story short, tapi sebab first time kita buat benda ni kan. Okay, now we want to get rid of the function in terms of t ni dekat sini. So you got to divide all the terms both side both side of the equation tu dengan e to the power 1/5. So the first term, the e to the power 1/5 got cancelled out, right? Plus ce to the power of negative 1/5t. Tak macam ni pun boleh. Are we done?
Not yet.
We are not done yet. Why? Why? Because we don't know what the C is,
Yes.
isn't it?
Yes.
Alright, so how do you determine the C? Look at here, okay? The C, this is an initial value problem, right? Why? Because you have an initial amount of salt, right? Where the X, the amount of salt at time T, or initially at T equals to 0, happens to be 7. Betul? Alright, so the tambahan sikit lah. X0 equals to 7. So this is an initial value problem. Okay, so by having that initial condition where X equals to 7 at T equals to 0, so you got to plug in the value whereas into the general solution ni. X happens to be 7 and the T happens to be 0, so this term becomes 1, right? E to the power of negative 0. 1 over e to the power 0 is 1. So you have 30 plus C, betul tak? So what is C then? Betul? Betul ke dapat 23 ni? Betul. Betul Okay. So therefore,
Particular solution is X equals to 30
yes,
minus
X of
23.
T goes
X of
to
T, okay.
30 minus 23 e to the power of negative 1 over 5 T. Okay, boleh faham?
Boleh.
I think I'm going quite slow juga kan. Saya tak nak tunjukkan yang inilah kan. Dah ada dah jawapan dia ni nampak ni. Jawapan dia dah ada, cuma saya nak explain je. Okay. Alright. So we are done with that. Okay, B, how much salt is present after 10 minutes? Okay, you have already yang ini adalah A lah A. Okay, untuk B, salt after 10 minutes X after 10 minutes.
T equals to
masuk je lah. 30 minus 23 e to the power negative 1 over 5 times 10, right? You replace the T. So dapat apa ni? Kira dapat berapa?
$26.89.
Alright, 26.89, something like that. Apa? Unit je?
Gram. Gram.
Okay. Right. So what will be the next questions? How much salt is present after a long time? Macam mana kita nak buat tu? Salt is present after a long time.
Limit. Ya ke?
Ya ke? Nabil orang Sarawak Nabil
Sabah.
Oh Sabah, saya tak beza orang Sabah orang Sarawak. Ke Sabah sebut bah belakang kan? Kalau orang Sarawak sebut apa
Entah.
Ada orang Sarawak kat sini. Natasha orang mana Natasha?
Sarawak kita Kamek, doktor.
Kita. Okay. Alright, itu je lain saya tahu. Okay. Alright, so ST goes to infinity. Alright. So agak-agak dapat berapa?
Infinity.
Ya ke?
Tak tahu.
Memang saya tulis kat sini. Tak cukup ruang. Okay, so C limit of xt goes to infinity. So you just you kena tahu konsep dia, kenapa xt goes to infinity after a long time lah kan. Tak tahu long time tu how long is long lah. Okay, so you just replace the xt with 30 minus 23. Yang ini sebenarnya boleh tuliskan macam ni kan, e to the power of 1 over 5t, betul tak?
Betul.
Okay, now what happened to this term? What happen to this term as t goes to infinity? If t is very large, so the 23 is divided by a
Zero.
very large number, right? So the limit is to 0. So as a result, the maximum amount of salt that is present in the tank after some time, after a long time, would be 30 gram. Faham ke? Kenapa dia kata macam tu? Macam larutan gula tu lah kan. Larutan gula kan dia ada kepekatan ya. After certain time, dia ada, kita sebut larutan, berapa banyak gula yang larut dalam tu. So bila dah kepekatan dia maksimum, dia tak boleh larut lagi kan. Kita nak tahu berapa jumlah salt yang boleh larut dalam larutan tersebut. Of course, if you keep on adding tadi cakap pasal apa, gula ke garam ke gula tadi kan, you masukkan gula, if you keep on adding gula dalam jug tadi tu, mungkin bila dia dah kepekatan dia dah maksimum, dia masih boleh menerima tapi dia tak boleh larut. Nampak tak? Dia akan ada macam residu kita panggil kat bawah tu kan, betul tak? Sebab dia tak larut. Faham ke? Macam itulah konsep dia begitu. Okay? Alright. Okay, if refer to the notes memang dah ada solution ni kat sini, saya dah beri. Maknanya you tahulah what's going on, yeah. Right, so this is the working. Alright. Okay, ada soalan nak tanya before we proceed to the next one? Any questions that you like to ask before I proceed to the next one?
Tak ada.
Tak ada. Okay, kalau tak ada, kita proceed to example number 2. Okay, example number 2, tank A which can hold up to 10 liters of liquid initially contains 200 liters of pure water. Okay, nampak tak perkataan apa? Pure water. Kalau yang tadi, dia masukkan larutan garam kan? Dia ada concentration, betul tak? So kalau pure water?
Air kosong.
Air kosong
Air yang tak ada apa-apa.
Dia punya ais kosong. Pernah tengok tak TikTok tu? Bulan puasa kan, ais kosong. Okay, alright. So dia masuk pure water. Pure water maknanya apa? dx dl, the concentration would be? Zero. Okay? Alright, kita tengok apa maklumat yang kita ada. A tank which can hold up to 10 liters of liquid. Maknanya maksimum capacity tank ni adalah berapa?
1,000 liter.
Okay, 1,000 liters. Alright, and the liquid dia kata initially contains 200 liters of pure water. Okay, silap saya tersalah. Sorry. Itu problem lain saya pun tak rasanya ni. Sebenarnya dia mengandungi berapa? Saya nak kurangkan sikitlah amount ni. Banyak sangat. Lukis balik semula. Okay, so this is the tank. Okay, so kita ada 200. Ni 200 liters of pure water. Okay, pure water. Okay, a brine solution. Dekat sini yang masuk brine, mesti air garam. With the concentration of 0.25 kg per liter enters the tank at the rate of 6 liters per minute. Okay, so maknanya the brine solution of concentration 0.25 kg. Ia dia bergantung kepada unit apa yang kita nak guna. Kalau nak maintain dalam kilogram, kena gunakan 0.25. Okay, 0.25. Kalau nak tukar pada gram, you kena jadi berapa 250 gram okay, so kata kita maintain dalam kilogram. Okay, and then the rate of the solution that goes into the tank is the LDT in equals to berapa? 6 liter per minute. Okay, right. Okay, now lepas tu at the same time the well stirred flows out the tank at 4 liters per minute. Okay, kacau masuk kat sini kan, dia masuk kat sini, dia masuk. Kacau, and then kita bagi dia keluar. Dia keluar at a different rate, right? So you have dLdt equals to 4 liter per minute. Okay. And then what will be the concentration in out? What will be the concentration of the solution that goes out of the tank?
X of
Yeah.
D
X of T
over
over something kan? Betul tak?
yes, something.
Okay. Kenapa saya letak something? Dia tak macam tadi senang-senang letak 10. Dia kenapa saya letak question mark kat situ?
Inflow outflow rate tak sama.
Yes. VT equals to what? Okay, mari kita tengok. The R in minus R out sama dengan berapa? 6 tolak 4 kan?
Ya, 2.
Okay. So maksud dia apa ni? Ni sama dengan 2 liter per minit. Betul? So maksud dia apa? Kalau 2 liter per minit maksud dia apa? 1 minit dia akan berkurang sebanyak berapa?
2 liter.
Okey. Dia berkurang ke dia bertambah?
Berkurang.
Nah.
Bertambah.
Dia masuk cepat, dia keluar lambat.
Betul.
Masuk cepat, keluar lambat. Bertambah lah kan. So maknanya ni dia akan naik ke atas lah kan volume ni. Okey. So berapa kadar pertambahan dia? What is the kadar pertambahan is 2 liter per minute kan?
Yes.
Betul tak ni?
Betul.
Faham tak ni?
Faham.
Yang lain faham tak? Tak dengar suara ni.
Faham.
Tinggal dengar je saya kan cakap ni. Dekat saya yang kering dulu ni. Okay. Amount of ataupun amount of increase in volume. Increase in volume. Ini positif kan? Betul tak? Okay. So dia adalah 2 liter per minit. Maksud dia 1 minit. Berapa tambah dia?
2 liter.
Okay. We were talking about T minute kan? So kalau T minute?
T liter.
Ya ke T liter?
Tak tahu.
1 minit 2 liter. Kalau 3 minit, okey saya cerita. 1 minit 2 liter. Kalau 2 minit berapa liter?
2 liter.
2 kali 2 lah kan.
4
Betul
liter.
tak? Okey,
Ya.
3 minit.
6.
6. Okey, seketul ayam harga RM3. 2 ketul ayam.
Yes.
Kali 2. Betul? 4
Betul.
ketul ayam. 2 kali 4, betul? Okey, so sekarang ni 1 minit 2 liter. Liters 2 liters. 2 minit 2 times 2 liters, betul? 3 minit
2 T liter.
okey, betul tak? So
Betul.
maknanya amount of volume sama dengan apa? Kenaikan, kadar kenaikan dia berapa? Yang asal dia apa? What will be the original amount? What will be the original amount? 200
200.
liter. Saya omit the unit lah Okey, tambah ataupun tolak?
2 T.
Tambah berapa? 2 T. Faham tak ni?
Faham.
Afrina, okey Afrina?
Okey.
Okey. So nampak tak? Dia macam ni je. Kalau rate masuk lebih tinggi daripada rate keluar, yang ini akan jadi tambah. So katalah yang masuk 4 liter per minit, yang keluar 6 liter per minit. What happened to the amount of solution in the tank? Increasing or decreasing? Kalau dia masuk 4, dia keluar 6. Decreasing. So dia akan jadi apa kat sini? Tolak. Okay? Alright. Boleh faham?
Faham.
Tu ni kena ingat lagi. Tak faham untuk tampi seseorang kat bilik dia. Okay, alright. So dapat apa ni? of the solution in the tank at time t is 200 plus 2t. Kita nak cari apa sebenarnya? Nak cari model. Model dia apa model dia? Bukan model baju raya ke petaan ni, model dia. Model dia apa? dx dt sama dengan apa? Saya tak payah tulis formula balik lah ni maksudnya apa? Dia punya yang masuk berapa ni? 0.25. Alright, darabkan dengan 6. Betul tak?
Betul.
Tolak berapa?
Tolak.
Okey lah, dia tak nampak lagi. Okeylah, kita simpan dia sekejap. Kita dah tahu volume tadi kan? Dah tahu volume tadi. Tengok concentration of the solution in the tank at time t. Concentration. Nak cari question mark tadi tu. Question of the solution in the tank at time t. Sama dengan berapa? Ct lah kan? Ct sama dengan berapa Ct? X of t divided by
200 plus 2t.
plus 2t. Are you all with me?
Yes.
Lemahnya. Sahur ke tak sahur ni?
Lapar tu doktor, lapar.
Sahur.
Celah je seorang-seorang lapar, yang lain tak lapar. Okey. dx dt sama dengan apa ni? Saya tulis balik. dx dl dl
dt.
in. Okey, minus dx dl dl dt out. Okey. Alright. So apa tadi? 0.25 darab 6. Tolakkan apa tadi? X of t divided by the volume kan? 200 plus 2t multiply berapa tadi? 4. Okay, alright. 0.25 kali 6 dapat berapa?
1.5.
1.5 sama apa? 3 bagi 2 kan? Okay, now. Yang ini kita boleh macam nak ringkaskan, boleh tak saya tuliskan X bahagikan dengan, saya suka ringkaskan sebab apa? Sebab dia akan memudahkan hidup kita lah. 100 tambah T, betul tak?
Betul.
Dia kalau 1 betul? So dapat
Betul.
berapa? Sila check. Ini model kita. Kita boleh rewrite the model sekali sama dengan saya ke? Ke saya seorang salin ni?
Salin sekali.
Salin sekali. Nanti boleh dua lepas raya ke? Sekejap. Nak ada first assessment lepas raya Okay. Alright, so dah bentuk macam ni kan? Okay, sekarang ni apa dia punya PT dia? Ini adalah linear kan? Okay, now identify the PT. PT is 2 over 100 plus T, betul? So what will be the integrating factor? F lah, tak payah tulis FT. F. Integrating factor sama dengan apa? Dia ada macam-macam jawapan nanti kan, okay? E to the power of integration of
2 over 100
plus T
dt.
Okay, kalau you tak nak simplify pun boleh. You tak nak simplify pun boleh. Nanti dia akan jadi kat sini dia lain lah dia punya tu. Tapi at the end of the ni jawapan mestilah sama. Okay, alright. So but I would prefer to simplify to the most simplified punya tu lah. Okay, sebab dia akan memudahkan kita punya pengiraan nanti. So here, you can actually take out the 2, isn't it?
Yes.
Yeah, if you take out the 2, dia akan jadi apa? I'm doing it step by step Nampak tak coefficient of T is 1 kan? So maknanya senang nak cari dia punya. So this is 2 log what? 100 plus T. Okay. Kalau ikutkan dia ada bentuk macam ni kan, tapi T will always be positive kan. You boleh omit dia punya you punya absolute value tu. Alright, you boleh omit sebab we are dealing with T positive, isn't it? So this term will always be positive, right? The reason why we put the absolute value is to ensure that the argument of the log ni adalah sentiasa positif. Okay, now what do I do next? Saya tak nak maintain dalam bentuk macam ni sebab nanti calculation yang lain akan jadi complicated. So what I do is I bring the 2 up, so you have what? You cancel out the E and the log. So you dapat berapa? Yes. Okay, so you multiply both sides of kita panggil this star with F tadi tu, right? So kita akan dapat 100 plus T to the power of 2, right? Multiply by you don't have to expand, and just write down the expression on the left hand side of the star ni, right? 2 over 100 because it does not matter lah you expand ke, you tak nak expand pun tak payah. So nak jimat masa kita biar macam ni je lah. Okay, now so this expression on the left hand side can be simplified into D dt, the integrating factor which happens to be 100 plus T squared, and then the dependent variable is xt, right? This is x, capital X, goes to 3 over 2 100 plus T to the power of 2. Okay, are you all with me?
Yes.
Right, dah dapat salin. Okay, so saya tulis balik. So ada 100 plus T to the power of 2x, right? And then seterusnya kita buat apa? Kita integrate lah kan, betul tak? Kan? Kita nak get rid of the derivative, kita integrate yang ini. Okay, so we have 3 over 2 integration of 100 plus T squared dt. Betul? Okay, saya tanya. You all nak expand benda ni dulu ke you all nak buat substitution?
Substitution.
Kalau saya sebab apa, coefficient of T ni dia macam linear kat sini kan, jadi macam dia punya 100 plus T tu macam linear, jadi saya buat substitution saja. So maknanya you akan dapat apa ni? On the right hand side, 3 over 2. Kalau you gantikan U sama dengan 100 plus T. So what will be du then? U dt lah kan? So you akan dapat in the bracket ni is U to the power of 2 du. So the resulting integration tu dapat apa? U to the power of 2 kan? Jadi apa?
3 over 3.
Betul?
Betul.
Kenapa jadi 3?
Sebab power 2 tambah 1.
So kita dapat apa ni? 1 over 2 100 plus T to the power of 3 plus K, right? Okay, and we want to get rid of the coefficient of X tu on the left hand side. We divide all the terms dengan 100 plus T kuasa 2. So this one becomes 1 over 2, put it in the bracket, 100 plus T to the power of 1 lah kan, sebab dah bagi dengan to the power of 2 tu. Okay, plus K over 100 plus T to the power of 2. Are we done?
Not yet.
Apa dia punya ni? Cuba tengok. Okay, initially contains 200 liters of pure water. Initially, the amount of the solution in the tank is pure water. So what can you say about the initial amount of salt that is present in the tank?
0.
Yes. So meaning that in mathematical form you can write the the information as x naught equals to 0. Okay. Right. So going back to our discussion just now. Ada tadi. Bagaimana tadi? Kat sini maknanya kita ada X0 equals to 0. So we just plug in the value. 0 equals to 1 over 2, 100 plus T happens to be 0, right? Plus K over 100 squared. Okay, can someone please calculate the K for me? Tolong kirakan K dapat berapa? K dapat berapa? Tolong kira guna calculator.
Tengah cuba.
Nak tinggi berapa? 50 kalikan dengan apa? 100 kuasa 2, betul? 500,000? Yeah. Macam tu? Okay. So, the amount of salt at time T in the tank at time T is what? Berapa ni? 100. Okay? Are you all with me?
Yes.
Right. So in this case, kita dia nak determine the amount of salt in the tank at time T dan calculate the amount of salt in the tank when tank A reaches its maximum capacity. Apa maximum capacity dia?
1,000 liter.
1,000 liter. Maknanya bila kan solution ni naik kan, bertambah kan by 2T kan tadi, the volume will be increasing at the rate of 2 liter per minute, alright? So maknanya the volume will be 200, the initial amount of substance of solution in the tank, you add up with 2T lah, jumlah kenaikan adalah 2T, and then dia akan reach the brim of the container ni. Brim tu maksudnya apa? Bukan bantuan rakyat satu Malaysia tu. Brim tu maknanya kita panggil apa mulut. Kalau cawan tu brim of the cup tu dia adalah dekat yang kita letak kita punya mulut tu lah, nak minum tu kan, kat luar tu. Okay, alright. So kita tak tahu berapa lama masa yang diambil, how long it takes for the the solution in the tank to reach the brim of the tank ni. Okay, so maknanya kita kena tahu T tu berapa. Okay, that can be found by mana tadi? So ini kita dah selesaikan kita punya ni. We just insert this slide. Okay, so yang B ni the maximum is kan dia naik ni. Yang ini adalah 1,000 liter. Okay, so volume ni akan menjadi 1,000 liter pada T berapa. Okay, so we need to know what the T is, and we know that the representation for the volume is 200 plus 2T, right? Equals to 1,000. Okay, VT equals to 200 plus 2T. So you solve for T lah. So you know that 2T is simply 800 and T happens to be 400 minutes. Unit dia per minute kan? Right, so we are not yet done yet. Soalan dia nak cari berapakah concentration, berapakah amount of salt in the tank when tank A reaches its maximum capacity. So we have identified that it takes T equals to 400 minutes okay, for the tank to reach the maximum capacity. Okay, alright. So maknanya, therefore, pada ketika dia mencapai 400, mengambil masa 400 itu, berapakah jumlah amount? So the amount of salt at time t ni, alright, and the amount of salt at time t equals to 400. Okay, equals to 400 minit tu equals to what? Equals to what? What's the model tadi just now? 100 plus 400 divided by berapa? Hello, are you all with me?
By 2.
By 2. Okay, minus
500,000 over
berapa tu?
1. Tak ingat dah.
Nah, itulah tak ingat.
100 plus
100 tambah T kuasa 2. 100, kita buat 100 tambah 400 kan? Kuasa 2.
Betul.
Okey, cuba kirakan berapa.
Dua, empat, lapan.
248. Berapa unit dia tu? The tank must be very big lah Dia ada 248. Setelah 40 minit. Cantik. Okay, boleh faham ke? Inilah ceritanya ni. Dia tak sesimpel example yang pertama kan? It's not as simple as the first one. The first one to rate in out sama tu, tak ada melibatkan increment increase or decrease in the amount of substance in the tank. So the calculation will be simple. Okay, but when you involve an increased amount of solution in the tank or a decreasing amount of solution in the tank, the steps would not be that simple. Okay, you have to be very careful when you first develop the model. Okay, itu yang sangat-sangat perlu diberi perhatian Okay, ada soalan nak tanya?
Tak ada.
Tak ada. Boleh faham Alright, so kat sini solution dia dah ada. I've already worked out the solution for you. Okay, so maknanya sudah terangkan tadi. Hopefully you know what's going on lah. Okay, now shall we proceed to example 2 or you need to take a break? Or we finish the example 3? Okay, ada satu lagi example saya nak bagi di example 3. Shall we proceed je? Proceed je lah boleh
Boleh.
Okay. You nak tarik nafas ke, nak stretch ke, it's up to you lah kan. Tapi kita buat pelan-pelan ni. Okay, example 3. Example 3, you want to take a break ni? Saya kena tanya ni, kan ada yang pingsan pula ni. Nak break sekejap ke?
Nak saya senyap ni tanda setuju.
Setuju apa tu? Setuju nak break ke setuju terus? Nak okey lah kita break sekejap 2-3 minit macam tu. Nak pergi basuh muka ke apa ke. Okay, we take a break. In a short while. Come back after we come back at 3:30 lah macam tu lebih kurang. Okay. So sambil-sambil tu siapa-siapa yang macam masih lagi segar tu boleh je try buat soalan ni. Okay. Jangan lupa tick your name dekat attendance list kat your future tu. Siapa yang tak datang ni? Ramai tak datang hari ni. Okay guys, we are back. Shall we proceed?
Yes.
All right. Okay. So we are going to discuss this example 3, and this one is actually from the textbook. Okay. A large tank is filled to capacity with 500 gallons of pure water. Okay. The unit that we are using here is gallon. Okay. Actually kita tak guna unit gallon ni kat Malaysia ni kan. Tapi kalau di if you are going to United States, biasanya dia menggunakan gallon. Saya tak ingat lah. Masa saya, I think 30 years back when I was in the state, memang dia masih lagi menggunakan gallon. So hopefully sekarang tak tukar lah unit ni. Okay. Tangki ni dia punya capacity adalah okay, dia kata is filled to capacity with 500 gallons of pure water. Okay. Okay, katalah ini dia punya tank, ini ada inlet dengan outlet ni. Brine containing 2 pounds of salt per gallon is pumped into the tank at the rate of 5 gallon per minute. Maknanya dia ada larutan garam. Okay, so you have, katalah kita define X to be the amount of salt. Okay, X, T is defined to be the amount of salt in the tank at time T. Okay, alright. So we have dx dl, concentration dia adalah 2 pounds of salt per gallon. Okay, alright. Saya omit the unit ni. Dia actually pound adalah lb, right? lb. Unit dia lb. lb over g lah. Okay, so the concentration is dl dt equals to 5 gallon per minute. G per min, min. Okay. Alright. So dia kata the well mix, dia masuk dalam ni capacity dalam 500 liter. Okay. The well mix solution is pumped out at the same rate. So maknanya dia tak akan ada perubahan dalam dia punya amount of solution in the tank. So it goes out at the same rate, meaning that the dLdt out happens to be 5. Okay, similar. Okay. Alright. So what will be the concentration then? dxd, ini in, ini out. What will be the concentration? X over? Anyone?
500.
Yes, X over 500. Ada tak tambangan berapa kali T? Tak ada kan? Tolak ke tak ada? Sebab dia masuk dengan keluar pada kadar yang sama. Okay, ni macam biasalah untuk A ni. Find the number of point of salt in the tank at time T. Macam biasa, you need to come up with the model. I do it straight away. So you have dx dt sama juga dengan 2 kali 5. Alright. Tolakkan dengan x over 500 multiplied by 5. Simplify 10 minus x over 100. Right. So you have the model. The equation becomes dx dt plus 1 over 100 x equals to 10. Okay. Alright. So macam biasalah, you nak selesaikan ni, you boleh selesai macam biasa. So dia punya PT equals to 1 over 100. So the integrating factor is e to the power of 1 over 100t. Betul tak? Okay. So you have, okay, we have D ataupun saya ni lah, saya tuliskan step yang tu. Okay, benda ni dah laju lah benda ni kan sebenarnya, sebab ulang benda yang sama je ni. Okay, multiply by dx dt plus 1 over 100 x equals to 10 e to the power 1 over 100 t. Okay. Alright, so you have d dt x multiply by e to the power of 1. Nak letak kat depan boleh, kat belakang, sebab it is a product. Okay. Alright, so integrate both sides, you get x e to the power of 1 over 100t equals to ni berapa ni kalau you integrate kan, ni dapat apa? Kan?
Betul.
Okay. So your x becomes what? Plus k over are you all with me?
Yes.
Alright. Okay. Lepas tu macam nak cari k?
Initial value.
Yelah, apa initial value dia?
Okay. Pure water.
So
X0 equals to 0.
So what is k then? So what is k?
Negative 1000. Yeah.
Alright. So the model becomes what? Ingat tak? Siapa ingat? Apa tadi?
X of t equals to 1000
1000
negative 1000 over e power of 1 over 100 t.
Betul. Okay. So this is the A kan? Betul tak? A ni the number of point. Okay, sorry. Dekat sini dia guna A Saya ni dah terikut-ikut. Saya nak guna A lah juga. Tak apalah. Tak payahlah serabut kan. Saya letak dia kepada X lah X kat sini. Sebenarnya A. Saya tak perasan dia suruh tulis A. Tak ada masalah. Okay. Alright, what is the concentration of the salt at time t? Now, how do you calculate the concentration? The concentration. Sorry for the sound ada sound effect pula tu. Dengan drill apa tu. Concentration. Macam mana kira concentration? C of T.
X of
X
T.
of T divided by the volume kan?
Yeah.
Okay, so kita ada apa ni? 1000 minus 1000. Saya nak tulis macam ni boleh tak? Boleh kan? Alamak, dia terlebih pula dia punya
Boleh.
negatif tu. Boleh. Nanti kita simplify mana-mana yang boleh lah ya. So E to the negative 1/100 divided by berapa?
500.
500. So dapat berapa? Okay. Right. See? What is the concentration of the salt after a long, okay, dia kata concentration at T equals to 5 minutes.
Substitute.
So maknanya C5 sama juga dengan berapa? 2 minus 2e to the power negative 1/100 kali 5. So dapat berapa? Roughly? Boleh kira lah ya. Dapat berapa ni?
Zero point 097 098.
Betul. Unit dia apa?
Apa tadi? Pound.
Ya ke? Pound apa?
Oh, over liter. Gallon. Sekati. Betul lah, gallon.
Bukan gram gallon. GL lah. Gallon. Okay. C apa soalan C tadi? Concentration of the salt after a long time.
Limit.
Apa tadi? Limit of the concentration after a long time T goes to 0. So limit, masukkan je lah. 2 minus 2e to the power of negative 1/100 T, right? As T goes to infinity. Nak buat dalam bracket macam ni pun boleh, tak nak pun tak apa. Okay, so dapat berapa? Boleh kan?
Tu.
Paling pekat dia boleh buat adalah 2 pound per gallon. Okay? Alright? Are you all with me? And then D, if the solution is pumped out at faster rate of 10 gallon per minute, when will the tank be empty? Macam tu. Kalau sekiranya solution ni dikeluarkan pada, ini current ni dia sama kan? 5 betul? Katalah kita ubah yang ni kepada 10. What happen? Ini jadi 10, dia keluar pada kadar 10 liter per minit, dia masuk 5. Apa akan jadi dekat ni? 500 kurang, betul?
Betul.
Okay, so bilakah tank ni akan jadi kosong pada satu persatu masa nanti? Bilakah masanya?
Tak tahu.
Tak tahu? Tengoklah volume. Okay, apa jadi dekat volume at time T? Okay, kita tengok dulu. R in minus R out berapa?
Negatif 5.
5 tolak 10 tolak 5 kan? Maksud dia berkurang sebanyak apa? 5 liter per minit. Maknanya, bukan liter, 5 gallon per minit. Maknanya 1 minit
5 gallon.
5 gallon. Okay. T minit?
5T.
Yes.
Gallon.
5T gallon. Ini apa ni? Amount? of decrease kan?
Yes.
Okay, so maknanya VT sama dengan berapa? Originally you have 500 liter, betul? Tolak ke tambah?
Tolak.
Tolak berapa?
5T.
5T. Okay? Faham ke?
Faham.
Ini maknanya amount of solution in the tank. Amount atau volume volume of solution in the tank at time T. VT equals to, saya tulis kat sini 500 minus 5T. Okay, so bilakah tank ni akan jadi empty? Bila V ni sama dengan kosong, betul tak?
Betul.
So T tu sama dengan berapa?
Dengan 100
Yes, T equals to 100 minutes.
minit.
So maknanya the tank will be empty after
100 minit.
100 minit. Okay. So nota dia kat sini, note the tank will be empty when T equals to 100. Kalau 100 101 minit,
Tak ada benda nak kosong dah kosong.
kosong jugalah, maknanya after lah, empty after T, after lah kan, after. Kalau can, when tu macam pada satu ketika tu je kan, tapi bermula pada minit yang ke-100 tu tank tu memang dah kosong dah. Okay, alright, boleh faham? Yang lain-lain macam mana? Okay?
Okey doktor.
Okay.
Okay. Nak tanya Afika. Okay Afika.
Okey doktor.
Salma, are you still here?
Okey doktor.
Okay, physically maybe tak ada kat sini tapi mentally kan. Okay, so that's how we go about solving this type of problem. Okay, when the rate is changing, right? Maknanya case yang pertama tu rate dia sama, case yang kedua rate dia lebih besar yang masuk, yang keluar tu lebih rendah, so dia akan bertambah amount of solution in the tank. So in another case whereby the rate of the solution that goes into the tank is lower as compared to the rate of the solution that goes out of the tank, apa akan menjadi? The amount of solution or the volume of the solution in the tank will be decreasing. So bila decreasing, dia akan tolak kat situ. Boleh faham yang tu? So kita ada 3 case ni, 3 main cases that you need to consider. Okay? Ada soalan nak tanya?
Tak ada.
Tak ada. Okay, kalau tak ada, saya tinggalkan you dengan beberapa soalan. Sekejap, mana soalan dia? Soalan ni. Actually yang ni kita dah discuss. Sekejap, yang ini saya tak pasti sama ke tak dengan yang tadi.
Lain.
Lain sikit kan. Okay, I leave it to you to solve example exercise 1 and example exercise 1 ni nombor 1 dan nombor 2. I've already given the apa nama ni, the final answer ni. Hopefully tak ada error lah dekat sini try it out first. Okay, boleh you may want to do it offline lah. Okay, ada soalan nak tanya? Kalau tak ada, I think we just stop here. Is that okay? Ke nak sambung? Ni tak ada respon ni.
Tak ada dah. Okay dah.
Okay dah kan? Nak sambung
okay
ke? Dah lah kot Yang ni sambung sendiri yang ni. You all are taking your own sweet time. Okay, dah 8-8 nanti tu nak sambung balik, nak tengok buat soalan ni pun boleh. Kita akan discuss lagi in the next class kalau ada soalan. Kalau tak ada soalan, saya tak nak discuss. Okay? Alright, but you have to do it first on your own. Okay? Boleh?
Boleh.
Boleh doktor.
You all nak jawab pun lemah ni macam mana ni. Kena kuat sikit ni. Okay. So saya nak tengok je what will be the next one. The next one will be electric circuit problem. We will be discussing this one next week insyaAllah. Okay, with that, thank you everyone. Assalamualaikum. You may want to download the notes in the Google Classroom. Okay, lepas ni saya minta you all guna official email Gmail untuk masuk dalam kelas lah. Boleh?
Boleh.
Okay, doktor. See you
Boleh.
insyaAllah.
Thank you, doktor.
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 Thank you, doktor.